Okay, so now we're going to demonstrate how to solve a second definition homogeneous differential equation. Now, consider the following problem. First, we have to check each power. It looks like that all of them are to the first power, but all the powers are the same. So we are able to use second definition. Let y equal ux, and therefore dy is equal to u dx plus x du. Now, we have the following. We substitute wherever there is y with ux dx, and then we have x minus ux times u dx plus x du equal to 0. Now, in this situation, we can actually combine dx's together, and we have x plus ux plus ux minus u squared x dx. From over here, this one becomes negative x squared minus ux squared du. Now, from over here, we're able to simplify a little bit further. So notice over here we have a common factor of x. So we have 1 plus 2u minus u squared dx equals to negative, we can factor out an x squared here, x squared 1 minus u du. From over here, we're able to get rid of one x. And we can probably move the negative to the other side, but I'm going to keep it for the following purposes. We're able to have 1 over x squared, 1 over x dx equals to 1 over u. I'm going to apply the negative here, so we have u minus 1 divided by, so I'm going to apply another negative. It's going to be u squared minus 2u minus 1, the integral, and this negative I'm going to move over here. Now, we get negative ln of x plus c equals to the integral of u minus 1 divided by u squared minus 2. So as such, we're able to first write it into this form. Now over here, we have to find what kind of substitutions we can use in order to solve for u. I'd say that u substitution, or rather a substitution, could work. Let t equal u squared minus 2, u minus 1. Therefore, dt is equal to 2u minus 2 du. Now, in this situation, we can actually factor out a 2 du. Now notice, that's why I kept the negative. So we're able to do that. We're able to do this. We divide by 2 to both sides. Therefore, u minus 1 du is equal to dt over 2. Now, we have the following. We have 1/2 the integral of dt divided by t equals to negative ln of x plus c. We get 1/2 ln of t, which from this substitution is u squared minus 2u minus 1, equals to negative ln of x plus c. By the exponential rule, or rather, we get the following. U squared minus 2u minus 1, when we substitute this back in, equals to negative 1 over x, by moving this power back, we have 1 over x times c. Or rather, this is a bit confusing. So let me do it step by step. When we move the 1/2 back, this becomes the square root of u squared minus 2u minus 1, absolute value. This one, when we move the negative, becomes ln of 1 over x plus c. When we take the exponential to both sides, we get the square root of u squared minus 2u minus 1 equal to 1 over x and then times e to the c, which is some kind of constant. So we put c over here. Now, of course, we can then square both sides. We get u squared minus 2u minus 1 equal to c over x squared. As discussed previously, doing anything to a constant or doesn't change that it's still a constant. So we can keep it as it is. Then we have our substitution. U is equal to y over x. Now, we get y squared divided by x squared minus y, 2y, divided by x minus 1 equal to c over x squared. Here in this situation, we actually can simplify this, but we don't have to. I'm going to do it just to demonstrate to you that you can. So we get y squared minus 2xy minus x squared equal to c. And as far as it goes, this is x squared minus 2xy equal to x squared plus c. And this is as far as we can probably simplify without disturbing any kind of changes that we might be able to make to it. Now, we can go a little further. We can probably do quadratic formula, but I think for now, this is the best that we can have it. And as such, this is how we do a second order. This is how we approach a second definition homogeneous differential equation. Thank you.